Building a professional trading robot requires two distinct components: a set of operational rules to govern entries and exits, and a trading schedule to define when the system is active. OtoAlgo is designed to translate a specific trading idea into a live automated strategy without the need for manual coding. By the end of this session, you will have constructed a functional architecture consisting of a rule set, scalable user variables, and a precise schedule set. This visual building approach allows you to formalize your strategy into a series of logical steps, removing the technical barriers that traditionally limit algorithmic execution to programmers. To begin, navigate to the sidebar under Strategy Builder and select Rule Sets to initialize a new blank configuration. Every rule is built from two components: conditions, which serve as triggers, and actions, which are the executed tasks. The condition logic field at the top allows you to determine how conditions interact using and/or statements to define the execution path. A common issue when first automating a strategy is the execution loop. This occurs when a robot repeatedly sends orders because the market conditions remain true over consecutive price ticks. You can prevent these loops by adding a guard condition. By checking if the robot position side is flat, the system ensures it only triggers a new entry if it doesn't already hold an active position. Setting these specific logic gates ensures the robot only interacts with market data when the criteria you've defined are met. Functions act as building blocks to pull market data into your strategy. For example, the range data function can be configured to calculate the maximum high or minimum low over a specific number of days. Once the conditions are established, you define the output in the action block. Here, you select order execution commands such as long, short, or close position. Beyond simple entry and exit logic, you must also define the state of the rule, which determines when it is active. While an active rule evaluates every price tick, you can use states like passive until next bar to keep a rule dormant until a specific event or time interval passes. On the right side of the screen, you can manage user variables, which serve as the strategy's internal memory. These can be used to store a specific value, like a calculated price level, at one point in the strategy, so it can be referenced by other rules later. You can also define parameters like lookback periods or stop-loss percentages here. This allows you to adjust the specific values of the strategy without modifying the core logic. Decoupling these variables from the logic allows you to iterate on different values during the testing phase to see how the strategy performs under different settings. Even with precise logic, strategies can be exposed to risk if they operate during periods of high volatility or low liquidity. The schedule set allows you to constrain the robot's activity to specific days and time intervals for each day of the week. Within the schedule settings, you can also enable the day closure protocol. This instruction overrides standard rules to automatically flatten all open positions at a specified time, preventing exposure to overnight market gaps. Combining a rule set with a schedule set allows you to define both the logic of the trade and the exact time windows for execution. The strategy architecture is now complete, including the rule set, the user variables for parameter management, and the schedule set for timing. The logic is formalized into a set of instructions that the system can now interpret and execute without further manual input. While the strategy is structurally sound, it must now be tested against historical data to evaluate its performance. Proceed to the next tutorial, where we will submit this blueprint to a historical backtest to analyze its results.